Hi, my name is Thomas Haynes, and this is a short postmortem on my computer science 442 final project, computer graphics. Now, this might not look super impressive to those in the know, but it is available online. You can try it for yourself. That will be down in the link. And hopefully, in going through with this postmortem, I'll be able to convey why I am so proud of this project. Now, to go very quickly over the kind of course of the course, it did start very basically. We were supposed to make a single triangle utilizing WebGL, and the entire course did use WebGL just to keep everybody on the same page. So everything did have to be done in a browser with JavaScript, that type of thing. But we did still learn a lot of important GL concepts. Now, I do have some experience from working in the games industry before, never in a big capacity, but I did make a fun little shader for the first project here, where we were just supposed to display a triangle. And yeah, similar to that, and embellish upon it. Here we added in a matrix, and that was to utilize matrices being pushed over to the GPU to move. So you could type them in there and move that. And then, of course, getting it to animate, move over time, and loading in some other meshes. If I can, yeah, click here. And then we moved on to getting some rotations and movements to work with perspective. So here you can see the cube looks like it's coming out towards you, and a little bit of a depth effect to highlight that. Whereas here, everything is orthogonal still. After that, we did some movement using the keyboard keys here. And yeah, so utilizing a camera type of setup, moving the camera in 3D space, having the objects appropriately react in 3D space, and then of course projecting all of that down to what OpenGL needs to properly render everything. And then just some texture mapping for here. Yeah, very basic, getting on a cube with a texture that we were provided. And then of course getting some lighting going. And here we have the controls as well. I have a few other controls set to the side. You can change the color of the light there. Very fun. And yeah, that brings us to the final project. Now, the final project was a group project, and I personally really did want to do something to wow the audience there. And I think I did. So again, this is all made in JavaScript, WebGL, but if you are in the know as to how this type of thing operates, you'll see quite a few features here. So we have the lighting that is reflecting off of things, and if I increase my speed there, you can see there is a light for the engine. There's a kind of a particle effect for the engine exhaust as well, and you may be able to see it. There are reflections on the ship, and the reflections are not homogeneous. If you look on the kind of engine bell, they're a little bit less there. Yeah, but there are reflections of the skybox around. And of course, we have the other rings that we can fly into, a little boost. And in getting this to work on mobile, I wanted it to be performant on mobile. So one of my design constraints, and you see I did get the kind of touch controls to work on mobile. These didn't scale with all screens, but that is a normal mobile design problem, is the DPI, and this was all from scratch, so I didn't want to do that. Yeah, that's a lot there. So we have quite a few features, but the biggest feature here is that all of this, every single thing, is made in one single draw call. And typically in games, other game engines that are out there, they will do batching. So things that are similar, usually similar materials, similar meshes, they will be brought together and put into a batch. So it's like one thing. Like you'll see this a lot with grass. All the grass uses the same material. It uses the same mesh. So we'll just draw that same thing a bunch of times. And here, I'm doing something similar. So I will show you the meshes that I made for this previously. This is Blender. This is where I made the meshes. Let's see, you have the ship here. a quad, the rings, and then of course this big thing out here. Now, one of the other students was working on the skybox, but we were getting down to the wire, so I kind of did a little hack to get it in there. There is just a giant inverted sphere around everything. If I turn on a back face culling, or a face orientation, the red here, this is the back, so the normals are facing inward to everything. And that is how we kind of got the skybox to work. Now, this HD spheres isn't the best way to do that, but it was done at kind of the last 4 hours of being able to turn it in. But what I am doing, and I will go into the code now, and this is the index for the page that's being served. Here are the controls, that type of thing. And all this should also be viewable on GitHub. The class is over now, so I can put it out there for people to check it out. And all of the various imports. Now, in all of this, it is just this one right here that was a library that was given to us by the professor, by the course. And that's just a small library of some helper functions with there, though we did have some issues with them, and I had to rewrite parts of it as well, because the errors being output were not super helpful. So close that, come back over here, and we have the mesh component. Let's see if I can find that. Mesh. So this is what holds all of our mesh data. They're all loaded in as OBJ files. Excuse me. Go to the main at the top. Yeah, we have a resource manager defined, and we're loading in all of the various meshes. And they get loaded into this object here. And it loads it in from a file, normal OBJ, that type of thing. And I believe at the bottom here, I have a lot of default shapes that you can just pull a mesh out as. And then we have a 2 render array. Now this is the one that was being used in the previous examples, and all it's doing is going through the data that we saved here from the OBJ file and pushing it all into one long array, because the way that OpenGL works is that it takes one very large array of just float numbers, and it just is massive. It goes on. And it does that for optimization reasons that are all handled on the GPU. So a little bit out of sight, out of mind, but you do still need to format the data properly to get it over there. Just one very long float array. And when you set up everything, here you can see the first thing I'm defining is the coordinates. Those are going to be the first 3 values, that type of thing. Next is color, 4 values. Normal, UV, and this one, a matte index. And that one got a little crazy. But we'll go back over the mesh. So we have to render array, and that's what this is doing. If it has normals as part of the OBJ file, it uses those. Otherwise, it just puts in some other ones and then returns that. Now, this is the one that's being used now, and this one will take in an integer, and that integer will be pushed into at the very end. Right here, I have listed out the position, the color, normal, and then the UV coordinates, and then at the very end of that one, if I bring this down here, we have our object index, OI. Yeah, so that is what that is doing. Now we'd have a separate thing, a mesh renderer, and that is because for the setup here, we used a component system similar to Unity. I do some of my personal projects now in Godot, but for here, I thought setting it all up similar to Unity would be a little bit faster for my team to work on. Now, if you want to, you open this up. If you just press the grave key or a tilde, the one right behind 1, tap it a couple times, this will pop up, and we have a full 3D scene inspector. Now we can click on root, and we'll see it has a transform. And we can go to our player here, and it shows the position. And if we move, and then we have to refresh it, it's not perfect, but you can see that it does update the position. And we have other components on there. The components, again, similar to the Unity engine, they don't have 3D space. They're just on these 3D game object type things. So we have the player, and that has a shift motor and all these other variables with it. And it has a collider on there. And you can see I have the particles system, and that instanced 4 particle objects, and those are right there. And each one of those should have a mesh renderer, yeah. And it's rendering the flame object. Fantastic. We have the racetrack, and that one, I believe, yeah, sets itself up in code as well. So it goes and makes the rings from the finish line. There were asteroids, but they got removed. That's what the collider was for. And then also the camera gantry, which is what I call my setups that move cameras whenever I work on a project. And then the world sphere, and that's the one that is being used to set up the skybox there. And yeah, because you have to have a mesh to get the pixels to render them. So we're just getting that and then using the coordinates appropriately to look up a proper cube map for the skybox. So that's how that works. Anyway, you go over here and you see we have the mesh renderer and ship. So if we go back over here, we can take a look at the mesh renderer in the components, and we do have quite a few mesh renderer. So very simple kind of setup here. We have a process function, again, similar to the other game engines that are out there. So here on the mesh renderer, we have a static function called compile mesh array, and that accesses the static variable that is just simply all of the mesh renderers that have been created. And what it does is it just goes through and makes one very big mesh with everything. And it applies an index to each of those as the final variable, as I showed you. But one of the issues that we ran into is the fact that with that big array that you're sending over to the graphics card, it has to be a floating point value. Now, JavaScript side of things, JavaScript doesn't really differentiate between numbers in that way. But in setting it over there, we are eventually going to use this index to index into a big list of all of the matrices. And that is where it's going to get a little complicated and wild. But what this does is it takes all of the meshes in the scene, and it is literally just one big mesh. They all share the exact same material. Everything is just broken down to a different material, or broken down to a different sector of those. And if we go here, we should be able to check those up. Yeah, so you can see down here is the ship. This is just the gold color. This is the flame color, and this was supposed to be the asteroids. So they all share the same textures, the same material, and interestingly, even the skybox does. So this is the vertex shader, and you can see we are taking in, we have this variable right here, or we have this uniform right here called model, and it is an array of size 61. And the reason it is size 61 is because that is the size that it needed to be to work on mobile. There's a limit to the total number of uniform variables or variable space that you have to bind. And since a mat4 is 16 floating point numbers, that got really big really fast. There could be some more efficient ways to do that, but I didn't end up having time for this project to do that. So in doing that, we take this single vertex shader, run it for all the vertexes, and when we go through, let's see if we can follow this one. Yeah, we unfortunately have to do the casting of the mat index over there. You can see that's the final attribute there. Casting it to an integer, and that is how we get the specific model matrix out of that. So one giant model matrix is passed over, a couple other big things, but again, you get a lot of savings because this is just one single draw call. It runs this once per frame, per vertex in your ginormous mesh, and then it runs this on every single pixel. This one doesn't need that same information. It's already been done, already been moved. It has the reflection cube map, and one of the tricky things that I did is to use the vertex color the alpha channel, because of course you can, when you're coding all this up, you determine what all of this means. The alpha channel here, if I can see where that is pulled out, this is where it gets a little confusing. I am using the alpha channel to determine if it is reflective or if it is a skybox. So depending on the alpha value, either the skybox would get sampled, and unfortunately that had to be computed already, or the normal view would be applied. So that is how I got the lovely skybox to work here as a single mesh to sample from a cube map instead of the other materials that were on here. And honestly, I think this looks very good. I do have a limitation in terms of the total number of things I can display, but honestly, that was part of the fun of the project. I do love hacking around with old-fashioned stuff and watching videos on things like the Nintendo 64, delving into those. So having that type of limitation of only 61 objects was pretty fun, especially because this game was multiplayer. I've turned off the multiplayer because that was causing some issues, but for the presentation I did in class, the multiplayer server was running. And that was just a very basic Python implementation of a WebSocket system. So what I did for my presentation is I showed a big old QR code on screen that opened the page linked to the server, and it just had a very basic packet sending to get everybody in there. And then, of course, because it was presentation day, everything braked and the race wasn't able to start, so everybody was just stuck at the start line. But I did get that to work, and the super mesh with the mesh renderer, this will only compile when there is a change. So every single time a new player joined, it had to get recompiled, stuff like that. And eventually it would run out of space. I did the math. There weren't enough students to cause an overflow, so that is just that's an error that's just sitting there that has yet to happen. But there's also differentiation for stuff like the hero effects. So if we have the main player here, and if we had other players join in, they would not have these effects. They wouldn't have the light effects around the exhaust as well, because this takes up 4 of our slots. These the particles here. It takes up 4 of our object slots. And again, we have fewer object slots than Nintendo 64 games. Nintendo 64 games, I believe, had 64 object slots near the end of that console's lifetime. But yeah, so in summary, just going through the main thing, we have a basic setup here for input audio management, loading in some resources, setting up basic objects like the camera, the world sphere, other things like that, the movement for the camera, all those variables. And we have a few functions for the game loop, and then we have Katara's hair, which runs 2 loops, because it's got 2 loops. Now it goes to the renderer, which is over here, which does get initialized. It's not a lit and is only initialized once because we have, if we go down here to renderer loop, it is just one draw arrays call. And since the arrays change infrequently, there's no batching or anything else. It runs at a smooth, stable 60 frames a second because it is locked by the fact that it is in a browser. If I have the time, I'd love to change this to be a C implementation or something more not bound by the frame rate limitations imposed by the web browser. That would be super cool. I would love to see just how fast this can go, since it is just one draw call. It doesn't need to shuffle anything around, and really just see how far I can push it. Like my daughter has a Raspberry Pi for her computer, and it would be awesome to get something that could play on that and be responsive. I am Thomas Haynes, also known as Kale the Quick online. I hope you enjoyed my admittedly rambly presentation here. But I'm very proud of this project. I think I did a lot of interesting stuff, and I really pushed the learning objectives of the course. So if you'd like to check it out, the links to the GitHub will be in the description, as well as links to my site where this is hosted. Thanks for checking it out.